Okay, next part of the chapter is natural logarithms. Now, the natural logarithm, ln x, is the inverse function of the exponential function e to the x. And the way we show that graphically is the inverse function will always be a reflection of the function through the line y equals x, because x becomes y, y becomes x. So I've got the graph here of e to the x, which passes through 1. So if I put in the line y equals x, then ln x is going to be a reflection through that line. It's going to look something like so. Okay, so with an e to the x graph, you've got exponential growth here, it gets bigger and bigger here. On an ln graph, it sort of plateaus off. It never stops increasing, but it increases slower and slower and slower. Same here, we've got an asymptote. Here we've got a vertical asymptote. So if you've got y equals e to the x, then e to the power of becomes log to the base e on the other side, which has got its special term ln. So when you've got e to the power of, it moves over, you get ln. When you've got ln, it moves over, it becomes e to the power of. So let's look at some examples then. Example 17. I solve e to the x equals 5. So very simply, e to the power of moves over and becomes log to the base e, which is ln. Now if it ever says work out the exact value, which it does in this question, you leave it like that. You don't put it into the calculator. Exact means leave as log, leave as e. Don't mess around with it. Don't use a calculator. B, ln x equals 3. So in this one, ln moves over, log to the base e, and becomes e to the power of on the other side. ln moves over and becomes e. Now, that might seem weird and abstract. What it actually means is 2.718281828 to the power of 3. So what it means, it's just going to be a number, but that's the exact value. Okay, example 18. Okay, solve e to the 2x plus 3 equals 7. And again, it wants exact form. So e moves over, it becomes ln, or log to the base e, which is ln. The plus 3 moves over to become minus 3. You can put the minus 3 in the end, but the danger is then you're going to write ln4, which is wrong. So let's put the minus 3 at the front, and then divide by 2. Now you can get an approximate by putting it to the calculator, but it wanted exact form, so you leave it like that. And then B, okay, so first thing to do, bring the plus 1 over, because you want to isolate the ln. Bring the plus 1 over, becomes minus 1. Divide both sides by 2. Then the ln moves over to become E. Okay, and C. E to the 2x plus 5 e to the x equals 14. Okay, and this is one you're just going to need to spot. And it kind of looks like a quadratic equation. So just rewrite it like this, it becomes more obvious. And then if I say let y equal e to the x, I get y squared plus 5y. So 14 is 0. You'd expect it to factorise. It's not guaranteed to factorise, but you'd expect it to, especially once an exact solution. So it's going to be 7 and minus 2. So y equals minus 7, y equals 2. Don't forget we went after y. Y is e to the x. So he moves over and becomes a log, or ln. If you remember, you can't have log of a negative value. There's no solution there. So x is ln2. Right, that's all the examples on this section. So now we'll go at exercise 14G.